Welcome to part two of this week. We're going to go over another, technically speaking, macronutrient that is an often confused yet highly important nutrition topic. This is water. Most of our body is made up of water, but believe it or not, most people are dehydrated at any given point. And that is kind of stunning because hydration versus dehydration, being hydrated versus being dehydrated, can lead to two very significantly different outcomes with regards to body function and health. Now, water ties in pretty nicely with electrolytes, and there is a good reason to cover water and electrolytes together. And this week we are going to do that, but to only a very minor degree. Mostly, we are going to keep electrolytes out of this lecture because water by itself is so important. So to break down this topic, we're going to start by going over the functions of water, and then looking at the consequences of dehydration, and then wrapping up with fluid intake guidelines. Believe it or not, we're mostly just water. We are primarily a liquid. More than anything else, we are that thing that comes out of the faucet in your kitchen sink. So about 60% of human adults are comprised of water. And then if you break that down further, as you can see on the right side of the screen, our organs and even our bones are made up of water. So hopefully that kind of gives you an idea of just how important water is, especially when you consider that essential organs like the brain, heart, and stomach are made up of a lot of water. So is water a macronutrient or a micronutrient? Let's consider what those things are before we answer that question. Macronutrients, those are needed in very large amounts. Micronutrients are needed in smaller amounts. That's the main definition of those two things. So with that in mind, consider that an adequate fluid intake for an average man is going to be 3.7 liters of water and 2.7 liters for women. And consider that 1 liter equals 1,000 grams. So we're talking about 3,700 grams of water for men needed per day, 2,700 grams of water for women needed per day. You compare that to something like carbohydrates, where you're going to need about 200 to 300 grams of carbohydrates per day. We need a lot more water than that. So with that in mind, technically water it's a macronutrient. We need it in very, very large amounts. Way, way more than we need carbohydrates, fats, or protein. Water is involved in many different essential life functions. In order for cells to live, thrive, and then perform their most basic functions, we need an adequate amount of water. In order for chemical reactions to take place, we need a medium in which they can take place, and water is a great medium or a solute. It also helps with temperature regulation of the body. And if you notice that after a long workout, you're cold on a day that really isn't that cold, this is probably because you're dehydrated. If you have joint pain from doing something like biking or running a long distance, there's a good chance that this joint pain could be from dehydration. A lot of times it's actually because of overuse, but in some cases, pain can come from dehydration alone because water surrounds and lubricates joints. And then also, water is a component of blood, which helps to transport nutrients, oxygen, and other chemicals throughout the body. Our cells are the basic unit of human life, and they are going to require water to sustain them and ensure that they function properly. Specifically, what water does is it's going to bring in nutrients and oxygen into the cells so that they can function and be fueled. Water allows chemical reactions to occur. It's a phenomenal solvent. And then finally, water is going to help to remove waste from the cells. So to reinforce on that last slide, when we talked about water's role in chemical reactions, what that means is that water is able to dissolve and break down chemicals into their most simple units so that they can interact very well with one another. And water is considered a universal solvent, which means that it's really, really good at acting as a solvent and dissolving chemicals. It dissolves more chemicals than anything else in the world. The reason that water is such a good solvent is that it's very polar. So it has very strong opposite charges. So one unit, the water has both very positive and very negative charges. So whenever another polar molecule, so again, another polar molecule, another molecule with very strong positive and negative charges, whenever that enters water, the different parts of it are going to be attracted to the different parts of the water. And because that pull from the water is so strong, it's going to rip those molecules apart and dissolve them into individual units. This slide here shows you what happens when a polar molecule is mixed in with water. So for this example, you can see what's going to happen when sodium chloride or table salt mixes with water. So if you were to take some salt and mix that with water, you would see that salt dissolve as you see the initial picture on the screen. But then the visual here is showing what's going to occur chemically to make that happen. So the red molecules, those are the oxygen. They have a very strong negative charge, and that's going to pull those positive purple sodium molecules away from the sodium chloride. Then the hydrogen atoms, which have a positive charge, are going to pull the negatively charged chloride atoms. This is going to eventually pull that molecule apart to the point where it completely dissolves in water and you cannot see any of it. Now, just so you know, this is as long as there is a sufficient supply of water. If you do not have enough water, then not all of the table salt is going to be dissolved, but with enough water, you're going to be able to dissolve and make that sodium chloride completely disappear in that water mixture. Another major role of water is that it provides volume to the blood. And what the blood does is it transports oxygen and other nutrients to various parts of the body. It's very important, very important. And consider that most of our blood is water. About 92% of our blood is water. So if we do not have enough water in our system, our blood levels are going to be a little bit lower. And if our blood levels are lower, things like nutrients and oxygen are going to be transported more slowly. So we're not going to be able to use oxygen and nutrients as quickly. So overall fueling and overall function of our body is going to decline. Another role of water is how it helps metabolize things. And that's important because without metabolism, there is no life. The definition of metabolism is all the chemical reactions that are involved in maintaining a living state of cells in a person. So a lot of metabolism involves converting food into energy or converting food into a specific piece of structure for the body or a specific function, as in the case of vitamins or minerals. The main thing is that it's going to process nutrients into things that the body can use to function and sustain life. From a simpler standpoint, it converts carbohydrates, fats, and proteins into energy. Water has a few specific roles within metabolism. First of all, it's going to allow nutrients to get to the cells where the nutrients can be metabolized because water is a component of the blood. Blood is what transports nutrients. Then water is going to be able to take the nutrients from outside of the cells and help transport them in. There's a lot that goes on with that, but the fact that water is there, it actually allows that process, that transport to occur. And then for ATP production, so whenever we're converting carbohydrates and fats and proteins into energy or ATP, for us to do this in sufficient quantities, water and oxygen are required. Without those things, many steps of metabolism cannot occur, and therefore we're only able to get a very limited amount of ATP from carbohydrates, fats, and proteins with the absence of sufficient water. And then again, finally, like we've discussed, water acts as a solvent. And water is inside of cells. So because it's inside of cells, it allows the necessary chemical reactions that need to occur to actually do so. So metabolism is kind of how we take some of those prior roles that we mentioned of water and really allow it to come full circle. So we can transport nutrients through blood, an adequate blood volume. It goes into the cells with the help of water. It actually is needed for various steps in ATP production, and the production of ATP to occur, and then it allows chemical reactions in the cell to take place. Water is really good at regulating our body temperature because it's difficult to change water's temperature. It requires a great deal of energy to do so. So consider what happens whenever you apply fire to a stick. It almost immediately starts burning, and that's true of most things. Say you were to put a stick in a pan and heat up the pan. It's going to get hot very, very quickly. What happens when you put a pot of water on your stove? Well, it is going to heat up. Um, but you can usually put your hand in that water for a period of time before that water actually gets warm. And this is when it's exposed to direct heat, to a burning flame, even when that flame's on high. The point of this is that it takes a lot of energy to change the temperature of water. And this is part of the reason why Lake Michigan does not freeze until the temperature outside has been below freezing for a very long period of time, days, weeks, months. Water keeps a stable temperature, and for that reason, it's a very good thing that we are made up of so much of it. Consider that 60% of our bodies are made up of water and that a lot of energy is needed to change water temperature. This means that our body temperature should be stable. Okay, I think you get that by now. However, what happens when we become dehydrated, even just a little bit? Does that affect our ability to keep ourselves warm? Challenge you to do a hard workout for an hour and not drink any fluid during or after the workout. Then go outside in the cold after you've dried off, of course. And then a day later, go outside being adequately hydrated, out doing that workout, and see how you feel. The difference will probably be not huge, but there should still be a noticeable difference. You're going to be colder if you're dehydrated and have less fluid to help keep you warm. All right, now let's consider the story of Aaron Ralston in 127 Hours. First of all, if you have not watched this movie, I recommend you do so. In it, a rock falls on a climber, trapping his arm between the rock and a canyon wall. Despite his best efforts, he cannot dislodge the rock. The hiker ends up trapped for 5 days before he ends up cutting off his own arm in order to escape. In the movie, they show the temperature dropping to as low as 40 degrees Fahrenheit at night. They also explained that he had a minimal amount of water available to him during this time, indicating that he was likely severely dehydrated. With only minimal clothing and the inability to move around to heat himself up, he became very, very cold overnight. But what the video did not mention that you can probably pick up by now is that the dehydration was also playing a very significant factor as well, making the 40-degree temperature that much more unbearable, make it feel significantly colder and more bone chilling than it would have been had he been adequately hydrated. The second of three sections is going to be dedicated to what happens during dehydration. And something to consider before we go into this, like we talked about earlier with the functions of water, our blood is mostly water. So when we're dehydrated, what's going to happen to our blood? We're going to lose a lot of that blood. So keep that in mind. Um, very important because this is like a severe, severe nutrient deficiency. Think about some of the problems that might happen if we're low in iron or low in calcium. Those are big deals. To not be able to properly send oxygen throughout the body, or to not have enough bone strength to withstand a fall without a break or a fracture. Water deficiency, first of all, can happen really, really quickly. And second of all, the consequences are severe. It can even result in death, and it does result in death in many, many cases.
Like we said in the last slide, one of the main functions of water is to serve as a component of blood volume. So when we have a low amount of water in our system or when we're dehydrated, our blood volume is also going to be a little bit lower. And because blood transports things throughout the body, this transport process, because there's a lower volume of blood, is going to be impaired. So this is going to make it harder for our body to perform basic functions. So you might notice when you're dehydrated, it's harder to exercise. And that's because the oxygen that's in our bodies cannot get to the muscles as quickly as it needs to for that exercise to occur optimally. Water deficiency or dehydration is incredibly common and it can occur very quickly with very significant consequences. It's estimated that about 3/4 of the population in North America is dehydrated on a pretty regular basis. And what dehydration means, like we talked about in the last slide, is that the transport of nutrients and oxygen is impaired. It's a little bit slower. So our body cannot use these things and carry out their essential functions as efficiently. Also, because there's less blood volume, our heart must work harder in order to pump blood, and our heart's able to do less. With less water, we also have a decreased sweat rate and an increased core temperature. Increased core temperature obviously means that we're getting warmer inside. The decreased sweat rate means that we're also less efficient at cooling ourselves off. We're also more likely to use muscle glycogen, which is our storage form of carbohydrate, and we want to be able to hang on to that and be efficient with that because once you run out of that, we're very low in energy. So we use the nutrients that we have more quickly.
Again, the reason that dehydration is so bad is because the consequences are so severe, and that's largely because of these two things. One, we're going to have a decrease in the amount of blood, and number two, we're going to have a decrease in oxygen and nutrient availability. More specifically, the biggest problem with dehydration is due to low oxygen, and this ultimately is what is going to cause severe kidney damage and death. Um, Blood carries oxygen, so oxygen is going to allow the kidneys to work effectively. And what the kidneys do is they get rid of waste products. They get rid of really toxins. If the kidneys do not have enough oxygen to do their job, they cannot filter out these toxins and they're going to build up and build up and build up to the point where, again, renal failure or kidney failure can occur, and we can even end up dying.
It does not take a whole lot to experience the negative symptoms of dehydration. At just 1% loss of body weight from fluid, which is very common and can occur through exercise and probably occurs for most people on a daily basis, at a 1% loss, we experience thirst. That's not really a problem, but it's a sign that we're starting to get a little low. At 2%, the amount of thirst that we have increases and it actually affects our appetite, and this causes our heart rate to go up. And it's at 2% that exercise is impaired. When we get to 5%, it's very difficult to concentrate, we're lethargic. We even have tingling extremities. At 8%, we experience dizziness and labored breathing. At 10%, we have muscle spasms and we cannot make clear speech. And then at 11%, we experience kidney failure. And this causes very poor circulation of nutrients and blood throughout the body. And at this point, this is when people typically go to the hospital. Now, obviously, exercise is going to cause us to have greater fluid needs because we're going to be sweating out more fluid, more water. But there's also some other environmental circumstances that can cause this. In very hot conditions, we're going to lose more water to sweat. Same is true in cases of high humidity with some heat. We have increased sweat rates to help cool off the body. At higher altitude, such as in Colorado, California, some places in Oregon, and even Washington, it's more difficult to breathe because there's less oxygen in the air. So we have to work a little bit harder to get oxygen into our system. Also, air at higher elevation is drier, and this dehydrates us naturally. Being at high altitude, because it requires greater efforts for breathing, can actually cause a condition known as alkalosis. And this is when our body becomes too alkaline, the opposite of too acidic. And what happens then is the body urinates to remove bicarbonate. And bicarbonate is very alkaline. And then that causes our blood pH to become more level. But in urinating excessively, we're going to be losing extra water. There's also some other life conditions that can cause increased hydration needs. In any case of trauma or illness, this can cause fluid losses to go up. Also, when someone's pregnant, this causes fluid needs to go up and fluid losses to go up as well. To have a better understanding of how significant dehydration can be and how quickly it can occur, let's take a look at a more extreme environment, the Grand Canyon. In the summer, in the Grand Canyon, it gets very, very warm. And with the canyon walls, what happens is the sunlight comes down and it bounces off the walls and heat becomes trapped in the lower sections of the canyon. And it gets very, very warm. So in the summertime, the average high at the bottom of the canyon is 106 degrees, very, very hot. Now, one study looked at accidents related to dehydration or heat-related illness, as the study called it, from 2004 to 2009. And during that time, there were 474 cases of dehydration, 6 of which were fatal. And throughout the time that people have been visiting the Grand Canyon and going to the very bottom of it, there have been many, many more deaths that have occurred due to dehydration. But this study just took a look at these years, 2004 to 2009. And what's important to know, and what's very interesting, is that even very fit individuals have died in the Grand Canyon from heat exhaustion and dehydration. Let's take a look at the case of Margaret Bradley. Margaret Bradley and her friend visited the Grand Canyon in July of 2004. Margaret was a phenomenal athlete. She had placed 15th at the Boston Marathon, and in her training, she was running up to 90 miles per week. That's quite a bit. She's one of the best runners in the country. So her and this friend, they planned a trip to run through the Grand Canyon that they believed to be approximately 15 miles. They miscalculated this trip pretty badly. Their trail was actually about 27 miles. So that's a big mistake right there. But perhaps the biggest issue is that Margaret only brought with her 1.5 liters of water. 15 miles into the run, her water was gone, and she and her partner were so dehydrated that they stopped running and sought out shade. After a few hours of waiting, Margaret decided to go ahead to search for help while her friend stayed back because he was feeling very impaired from the dehydration. Margaret made it a couple of miles down the trail, and although the details from this point are not very clear, she wound up succumbing to the heat to the point where she became immobile and eventually died from the dehydration. Margaret and her friends certainly could have prepared better, but her unfortunate trip is a demonstration that everybody, regardless of their fitness level, can very significantly and very quickly be affected by water loss and dehydration.
We're going to wrap this up by finishing with fluid intake guidelines. There's a lot to this section, but we're going to stick to the simplest and most basic practical guidelines that make sense for a large number of people. We talked a little bit about some of this stuff in the minerals section, so it might sound a little bit repetitive, but that's okay. It's still important information, so if we double up on it, it's all for the better. Um, so yeah, we'll talk a little bit about, again, some general practical guidelines for hydration.
We actually have a pretty cool mechanism for hydrating ourselves that comes from our body signaling us when we need to drink more water. And what happens is when our blood volume is low from dehydration, we also have a high solute concentration. And that means the electrolytes mainly. So what happens in that case is there's less saliva, so you have a dry mouth, and that's going to stimulate thirst. But just the fact that the blood volume is low, that tells our brain that we should be thirsty. So we have two things going on. We have that thirst sensation in our mouth, and then also our brain is telling us to drink. Then we drink water, and what happens is solute concentration normalizes or drops a little bit, and then our blood volume goes up. But we have this mechanism to regulate that whenever we're thirsty. And this is the best way to determine whether or not we should drink, is if we're thirsty. If we're thirsty, we drink. So how much water should we actually drink? Well, you may have heard that 8-ounce glasses is a recommendation for just about everybody, but this is actually a myth, and it's not really based on science. Fluid needs vary significantly between each individual, and it's more so based on weight than anything else. But there are some very significant environmental impacts that play a role into how much water a person needs. So geography and climate, these are going to have an effect, like we talked about with altitude, heat, and humidity. And then also a person's physical condition. So if they have an injury or a severe illness, that's going to cause their fluid needs to increase quite a bit. What experts have come up with, and what seems to be the most effective hydration technique, is to let thirst be our guide. So just go off thirst like we talked about a few slides ago. If you're thirsty, drink. This doesn't mean chug, but if you're thirsty, if you feel a mild sensation of thirst, drink a little bit of water. The first group of minerals is known as the electrolytes. The most significant electrolytes are sodium, potassium, and chloride, but calcium and magnesium also function in this group. Electrolytes help to regulate the fluid balance in our body. They also promote nerve and muscle function, and they help to regulate our blood pressure. Electrolytes generate an electrical charge either inside or outside of the cell, and this is how they help to perform their functions. Electrolytes work through a process known as osmosis, and through osmosis they regulate fluid balance, and the fluid balance that we have is compared to inside the cell versus outside of the cell. We have sodium and chloride on the outside, and then potassium is on the inside. So if we have more potassium in our body, what's going to happen is the water in our body is going to go inside of the cell. If we have more sodium and chloride, then the water is going to move to outside of the cell. So let's say that we're dehydrated and we would then have more sodium chloride outside of the cell. So if you look at that picture, on the right side of the cup on the left, so we're looking at the cup on the left, but the right side of it, that is the outside of the cell in the case of dehydration. There's a lot of sodium chloride. So what's going to happen is the water that we do have, even though it's a limited amount, it's going to leave the cell and go over to the right side where all the sodium and chloride is, like you can see in the picture of the cup on the right. But if we have the appropriate amount of these electrolytes, cells are generally hydrated optimally, as long as we drink enough. This little chart here provides some hydration guidelines for various durations of exercise under a variety of different environmental circumstances. However, the main takeaway from all this is that for anything that's less than an hour, all that you really need is water. But for anything that's longer than that, then fluids and electrolytes should be considered in order to obtain optimal performance. You can exercise for longer and not take both of these things. Many people will even exercise for 2-3 hours without drinking anything, but it's almost guaranteed that you are going to experience some type of performance and exercise decline if you're not hydrating properly. Caffeine and alcohol have a very interesting effect on hydration status. There's something that's called the antidiuretic hormone, and what this does is it causes us to hang on to water in our body. So caffeine and alcohol, they inhibit the release of this antidiuretic hormone. Let's break down that word just to the diuretic piece. What diuretics are agents that cause the release of urine. So they cause us to have to go to the bathroom and lose water. The antidiuretic hormone, is going to have the opposite effect of releasing water. It's going to cause us to retain water.